Hey guys, I made this video lesson for you. I hope you can hear me. I know this is probably my 7th time trying to record without static. I don't know how to get around it. So I just want to give you a heads up about the video. If I go too fast, hit the pause button so you can copy things down. You can always rewind and rewatch it, but please make sure you're filling out the notes because once you finish the notes, you're going to show them to the substitute and then you will get the assignment for today, and then once you turn that in, you'll get the homework for tonight. All right, so here's a few things. We're going to be talking about simple probability. This is the definition of an experiment. It's an investigation or procedure with varying results. An example of an experiment would be flipping a coin. The outcome or the possible results from the experiment. One possible outcome would be flipping a heads. The sample space is the set of all possible outcomes. Well, considering a coin only has two sides, the sample space would be heads and tails if I was flipping a coin. Let's look at an example. All right, some of these things you're going to have to retrieve old information from maybe geography or whatever. Maybe you need to get a calendar. Any of the probabilities with a deck of cards, I have posted a standard deck of cards infographic in our Unit 7 folder, so you can look that up in school to help you with your assignment. All right, so this is an example. It says, give the sample space and number of outcomes for each experiment. A state that begins with the letter O. Well, I'm like, okay, so I know Ohio, that's close. Oklahoma. And I believe Oregon. So it has three possible outcomes that we choose a state, and it begins with the letter O. Second example says a day of the week is chosen. Well, how many different outcomes do we have? Well, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That gives us 7 possible outcomes. All right, probability. What is probability? It's the measure of the chance of a specific event occurring. So if you look here, noted as P of E. This means the probability of the event, right? Probability of the event. It's expressed as a ratio, which is AKA a simplified fraction, of favorable outcomes, that would be the numerator, what you're looking for, favorable outcomes, to the total number of possible outcomes. So I always say it's what you want over what you have, right? The ratio can be written as a fraction. You guys love fractions. It can also be written as a decimal. And it can also be written as a percent. Now, you should be familiar with percents and decimals, right? And then a fraction, I always tell everybody, see the decimal, say the decimal out loud with words, and then write the fraction. Just a quick example, if I had 2/10, that's what this decimal is. 0.2 is 2/10. If I write that as a fraction, 2/10, that simplifies to 1/5. All right, I know you have your fancy little calculators, but it's cool to have a big brain too. Anyway, another fun fact about probability is the sum of all probabilities in a sample space is equal to 1. Whoa, that's crazy. Because it's like 100%, right? All right, let's do some more examples. All right, given each probability as a fraction in its simplest form, a decimal and a percent. So we're going to practice writing fractions, decimals, and percent. First, we're going to start with a fraction because that's the easiest thing here. All right, so the spinner below is used in a game. If it is spun once, find each probability. The probability of spinning a 9. Well, look at the spinner. How many 9s do I have? I have 1. Out of how many total choices? 16. 1 out of 16. So what I want you to do is get out your fancy little calculator. So get out your fancy little calculator, sorry I had to pause for a second, and take 1 and divide by 16 and tell me what that decimal is. That is also 0.0625. To find out what the percent is, you take that decimal and you multiply by 100. So if I take, it's already in my calculator, just times by 100, and that gives me 6.25%. All right, probability of at least 12. We already know what that means. At least means greater than or equal to. So that would be 12, 13, 14, 15, 16. So how many choices is that? That's 1, 2, 3, 4, 5. 5 out of 16 possible choices. So all you need to do is get your fancy little calculators out and do 5 divided by 16. That gives me 0.3125. Multiply that times 100, then this will tell us the percent. 31.25%. All right, a perfect square. Oh, now we got to use our big brains and think about it. All right, we got to think about our perfect squares. Well, 1's a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square, 3 times 3 is 9. And 16 is a perfect square. 4 times 4 is 16. Perfect square, remember, it's two of the same numbers multiplied together. Okay, so that gives us 4 choices. 4 out of 16. Now, it has to be a simplified fraction, right? So 4 out of 16 is actually 1/4. 1/4 is a decimal, hopefully you guys know that, is 0.25. I multiply that times 100, and that gives me 25%. All right, let me erase my little stuff here, and the next one is the probability that it is not shaded. So let's look at all the ones that are not shaded. Well, I have 1, 2, 3, 4, 5, 6, 7 out of 16. Quite a few. So 7 divided by 16 gives me 0.4375. Multiply that times 100, and we get 43.75%. All right, we're almost done with this example here. Erase my stuff. All right, next it says probability of a 2 or an 11. So what I want to do is I want to both. We have the probability of both. Either I get a 2 or I get an 11. That gives me 2 choices. Out of 16, we'll simplify to 1/8. All right, 1 divided by 8 is 0.125. We times that by 100 and get 12.5%. Fabulous! All right, one more example here with this spinner. It says, what's the probability that it is a multiple of 5? Multiples are things that go up. 5 times 1 is 5. That's 1. 5 times 2 is 10. 5 times 3 is 15. That's it. I only have 3 multiples of 5 in this spinner, so 3 out of 16. That does not simplify. So I'm going to get my fancy little calculator and say 3 divided by 16 and get 0.1875. If I multiply that times 100, that gives me 18. That does not look good. 18.75%. All right, easy enough. You guys are pretty smart. You can do this. All right, let's turn the page and do some more examples here. All right, it says for number 4, a month of the year is chosen at random. Find each probability. What is the probability it starts with a J? Well, you got to think about all your months that start with J. January, June, and July, right? So that's 3 out of 12. 3 out of 12, which is 1/4, which as a decimal, because you still need to write it for decimal, is 0.25, and as a percent is 25%. All right, the probability, it starts with a T. Yeah, so there are no months that start with the letter T, so that would be 0 out of 12, 0. The decimal is 0, and the percent is 0. So easy. All right. Probability that it has at most 30 days. Oh gosh, we talked about this little saying. 30 days has September, April, June, and November. All the rest have 31 except February. And there's a knuckle trick. If you start with your pinky knuckle, all the big parts of the knuckle is 31, and then the little divot's 30. So January, I'm visualizing it making my hand. Yeah. Anyway, so that's it. So that gives us 4. Oh, at most 30 days. Oh my gosh. Hold on. I was thinking all the ones that have 30 days. At most 30 days. I'm going to go back to my saying. 30 days has September, April, June, and November, and then there's February that has 28, which is less than 30, so it's not 31, so we have to include February. So that gives us 1, 2, 3, 4, 5. 5 out of 12. If I divide that and get the decimal, that gives me 0.4167. If I multiply that times 100, that gives me 41.67%. That was crazy. All right. Number 5 says the letter of the word probability is chosen at random. Find the probability, or find each probability. The probability of getting a B. Well, how many B's are there? There's 2 of them. That's my numerator. Out of how many total letters in the word probability? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2 out of 11. It does not simplify. As a decimal, it's 0.1818. And then as a percent, multiply by 100, and I get 18.18%. The probability of a vowel. Well, we know vowels, A-E-I-O-N-U. So, A-I-I. So there are 4 vowels here. All right, our sample space did not change. It's still the same number of letters, but now we have 4 out of 11. Which is 0.3636, and that gives us a percent of 36.36%. If the decimal is longer than 4 decimal places, please let's not write it down. We're just going to go out 4 decimal places just to give you a heads up. All right, for the last one, C, it says the probability of an I. So, I'm sorry, I don't know why I said I. Of a Y. Well, there's only one Y in the word probability, right? So that's 1 out of 11. Which is 0.0909. If I multiply that decimal by 100, I get 9.09%. All right, good. Let's look at number 6. All right, a pencil box containing 5 red, 6 yellow, 8 blue, 3 orange, and 2 purple colored pencils. Using that up to nothing. Period. If one is chosen at random, find each probability. Well, the probability of getting a yellow. How many yellows do I have? I have 6. So 6 out of how many total pencils do I have in my pencil box? 5 plus 6 plus 8 plus 3 plus 2 is 24. 6 out of 24 is 1/4, which is 0.25 or 25%. The probability of blue or purple, we have to consider both, right? Blue, 8, and purple is 2. So 8 and 2 is 10. That gives us 10 out of 24, which simplifies to 5/12. 5 divided by 12 is 0.417. If I multiply that times 100, it's 41.7%. All right, probability of not orange. So we have to exclude orange. It's like the opposite, okay? So if there's 24 total or colored pencils and 3 of them are orange, 24 minus 3 is 21. So 21 out of 24 is the probability of me not getting that. And if we simplify that, that gives us 7/8. And 7/8 as a decimal is 0.875. Multiply that times 100. 87.5%. All right, that's that one. For number 7, a deck of cards is chosen at random. Find a standard deck of cards. From a standard. Oh. Yeah, I can read. Don't worry, guys. It'll be fine. All right, so like I said, if you need a graphic organizer to look at so that you can identify what the cards are, it's in Schoology. I'll show you in a second here. All right, see this graphic here? This is a standard deck of cards. There's 52 total cards. There's 4 different suits. So if you need that as a reference so that you can complete this work, then you're more than welcome to do that, but you can follow what I'm doing. All right, the probability of choosing a queen. There are 4 queens out of 52, which gives us 1/13. 1 divided by 13 is 0.0769. Multiply that times 100, and I get 7.69%. All right, the probability, it's a red 3. Well, half of the deck is red. So there are 2 red 3s out of the entire deck. So 2 out of 52, which is 1 out of 26. 1 divided by 26, 0.0385. Times that by 100, and it's 3.85%. All right, the probability, it is a spade. Well, a spade is 1 suit of cards, right? So there are 4 different suits in a deck of cards. There are 13 total cards in each suit, so there are 13 spades out of an entire deck of cards. So that would be 1/4. Giving us 0.25 or 25%. All right, now the other thing I want to talk about is complement of an event. So it's like the probability of it not happening, okay? The complement of an event is a probability of the event not occurring. Since the sum of all probabilities in the sample space is 1, the probability of an event not occurring is 1 minus the probability of the event. I know it seems kind of weird. So we just figure out the probability of it and then subtract. All right, so it says in 8. If the probability that it will rain tomorrow is 3/8, what is the probability it will not rain tomorrow? Well, 1 minus 3/8 is equal to 5/8, which is 0.625, which is 62.5%. All right, if the probability that someone will win a game at the carnival is 1 out of 24, what is the probability that they will not win? 1 minus 1 out of 24 is equal to 23 out of 24. Which in our simple calculators is 0.9583 or 95.83% is the probability that you're not going to win at a carnival. How sad is that? Of course I want to know the kind of job. All right, number 10, a number from 1 to 20 is chosen at random. What is the probability that is not prime? All right, from 1 to 20, the numbers that are prime are 2, 3, 5, 7, 11, 13, 17, and 19. That is 1, 2, 3, 4, 5, 6, 7, 8. So 1 minus 8 out of 20, sorry I didn't simplify that, but that'll be fine, is 12 out of 20, which is 3/5, which when I put that in my fancy little calculator, that gives me 0.60 or 60%. These are prime numbers here. All right, 11. If a state is chosen at random, what is the probability it does not begin with the letter M? Now we got to think about all the states that start with the letter M. We have Maine, Maryland, Michigan, Minnesota, Montana, Mississippi. Sorry, I'm gonna have to bust the dust out my geography book. Let's go 2 more. All right, Maine, Maryland, Michigan, Minnesota, Montana, Mississippi. Please hold. I gotta get out my Google.
Massachusetts.
Hey yo, there's Massachusetts. Thank you, Google. I'm just gonna abbreviate it because it's so long and I'm already taking long enough. And we got Minnesota. We don't have Missouri. That's the other one. I just Googled states that start with the letter M. I knew that there was 3 different. All right, so that means 8 out of, well, we know how many total states we have, right? So 1 minus 8 out of 50 is going to be 42 out of 50, which simplifies to 21 out of 25. As a decimal, that would be 0.84. Ooh, my study. And as a percent, it would be 84%. All right, that's lovely. Now that you're complete, you can show the substitute your notes, and then she will give you the maze. So it's a probability maze. It is due at the end of the block. Please show all your work. Attach it to the maze with a staple. I have lined paper throughout the room. Help yourself. Once you're done that and submit that, she will give you the homework for the day. Okay? And I hope you guys have a great weekend. Thank you so much. Goodbye.